video is on multiplying fractions. All right, so the really nice thing about multiplying fractions and dividing, you'll see later too, is that you do not, and I repeat, do not need a common denominator, okay? So do not need a common denominator. So all you really end up doing is multiplying. You multiply the numerators, so 4 times 3 is 12, and you multiply the denominators. This is going completely against what we talked about with the adding, but since you don't need a common denominator, you just flat out multiply those denominators, and that's your answer. Now, at this point, you got to simplify. But let me show you a trick to make simplifying a little easier. Instead of simplifying when we have our answer, 1290s, let's go back a step, and let's simplify before we even do our work to get our answer. So what you're going to do is you're going to look, and you're looking for a number in the numerator, like 3, and a number in the denominator, like 9, that have a common factor. 3 and 9 can both be divided by 3, okay? So since they can both be divided by 3, I'm going to go ahead and do that. So if I divide 3 by 3, I get 1. 9 divided by 3 is 3. Same for 4 and 10. They can both be divided by 2, so I'm going to divide them by 2. I get 2 and 5. So I look, in the numerator I have a 2, but it doesn't go into 3 or 5, and I have a 1, so that's where I simplify as much as it can be. So at this point, I have no more simplifying I can do. And now I'm going to multiply what's in the numerator now. 2 times 1, I get 2, over 3 times 5 is 15, and that's my answer, and it's simplified. Okay, so as long as you simplify ahead of time everything you can, your answer will be simplified and you don't need to worry about it. What's nice is normally the numbers in the original problem are a little easier to simplify than your final answer. Okay, so that's why it's smart to do it this way. All right, so this one, if we have a whole number, but remember we've talked about this before, anytime we have a whole number, if I want to make it a fraction, you put it over 1. 8 over 1 is the same thing as 8. And now you can see what to multiply, what to simplify. So let's do some simplifying first. 8 and 6 are both divisible by 2. So I'm going to divide them both by 2. And then I look, 5 and 4, neither of them have anything with 3. So that's as simplified as it can get. And I go 5 times 4 is 20. 3 times 1 is 3. And that's my answer. Okay? You can leave it like that. That's completely fine. If you're someone who likes to turn it into a mixed number, you can. That would be 6 2/3. So go ahead, pause it, try this one on your own, and then hit play to see if you got the right answer. Make sure you simplify. All right, so let's do our simplifying ahead of time. 14 and 7 can both be divided by 7. 3 and 15 can both be divided by 3. And I've simplified so much, this just is 1. So 2 times 1 is 2, 5 times 1 is 5. And that's our answer, 2/5. So simplifying ahead of time can save you a lot of work. All right, same thing here. Hit pause and then hit play to get your answer. All right, let's look for some simplifying. 6 and 9 can both be divided by 3. 5 and 55 can both be divided by 5. Make sure you fill in this 1 here because you don't want to forget about what's there. Now we're going to do our multiplying. 2 times 1 is 2. 3 times 11, 33. And that's our final answer. Now be careful, double check your final answer is simplified because sometimes you might miss something in the original problem. So you want to make sure you didn't just miss out on anything. All right, when we have 3 numbers, not a whole lot changes, but you can simplify as long as it's something in the numerator and something in the denominator, they can simplify. For example, 3 and 12. They can both be divided by 3, so I simplify it to that. 7 and 14, they're all the way across from each other, but 7's in the numerator and 14's in the denominator, so I can divide them both by 7. 11 and 44, 11 goes into 44 4 times, and there's our answer. So this is as simplified as we can get, because in the numerator, they're all 1s. In the denominator, I got 2 times 4 is 8. 8 times 4 is 32. So 1/32 is our final answer. And you know that's simplified with a 1 in the numerator like that. So go ahead and pause it, try this one on your own, and then hit play to see if you're right. All right, so we got a lot of simplifying we can do. 2 goes into 34. Becomes 1. Half of 34 is 17. 15 and 20 can both be divided by 3. So that's 5 and that's 7. 5 can go into 20. Look, you can do this into something twice, right? So that becomes 1 and that becomes 4. And 17 and 17 are both divisible by 17. So that was a lot of simplifying we can do. And you're allowed to do that. You're allowed to divide something twice, simplify with 2 different numbers. So in the numerator, it's all just 1s at this point. In the denominator, it's 7 times 4. And I get 1/28 as my final answer. All right, word problem. So it says 3/5 of the students in 7th grade play a sport. There are 165 students. How many of them play a sport? So let's look at these keywords. We got 3/5 of. Hopefully you're all yelling in your little heads. Of means multiply. Okay, so of is multiply. You might guess because this whole unit is on multiplication. Multiply. But of means multiply. Let's slide that back up. There we go. So it says 3/5 of the students. So 3/5 times the students play a sport. Okay, so 3/5 times the students. Well, there are 165 students. That means 3/5 times 165 is how many play a sport. So I'm going to do 3/5 times 165. Remember, 165 I'm going to do over 1. So you can do some simplifying ahead of time because I know 5 goes into 165 since this ends in a 5. So 5 divided by 5 is 1. 165 divided by 5 is, let's see, that'd be 3 times again, 33. Okay, so you can do the long division if you need to, up to you. And what's nice here is now we just have 3 times 33 is 99. 1 times 1 is 1. Now remember, when you have a number over 1, that's just the whole number. This is just 99 students. I don't need the over 1 part, which makes sense because I shouldn't get a fraction answer because we're talking about how many people play something. I can't have part of a person, right? So I should be getting a whole number anyway, so that is showing me I'm on the right track there. So 99 students, 99 whole students, no parts of students allowed here. All right, so you can run 1/8 of a mile in a minute. How far could you run in an hour at the same pace? Okay, so we got 1/8 of a mile, we're multiplying, in a minute. Okay, so 1/8 every minute. How far could you run in an hour at the same pace? Now the problem right now is we have 1 hour and we have 1 minute. Those aren't the same thing. So instead of 1 hour, what could I say as far as minutes? 60 minutes, okay? So you can run 1/8 of a mile in a minute. How far could you run in 60 minutes at the same pace? So now we know we're multiplying our 1/8 times 60 minutes, 60 over 1. Okay, so we're going to look at that, see if we can simplify it. So 60, you could, if you want, just start dividing it by 2, right? You can divide by 2, divide by 2, and then, oh, look, we can divide by 2 again, 15 and 2. And then look to see if you can divide by 2 again, you can. Okay, so it ends up being 15 over 2. And this is one example where the improper fraction doesn't really make sense to leave it like that. You're asking how far could you run. You normally don't go, oh, I can run 15 halves of a mile. That's weird. So go ahead and change it. That would be 7.5 miles. And so this is an answer that makes a lot more sense. If you tell someone I can run 7.5 miles in an hour, they know what you're talking about as opposed to 15 halves.